Hey guys, Dave Ashenbrenner here, and this is part 2 of my evaluation of the TRONXY X3s. And it started out to be just kind of a discovery in what is the TRONXY X3s, and it kind of turned into I fell down a rabbit hole and ended up repairing a bunch of stuff when I went to assemble it. And it was kind of a surprise to me that they would put something like this out on the market with this many little problems with it. But I did kind of a comprehensive video, and as we went along and assembled it, I fixed these problems. It took, I believe, 5 eccentric bushings and 5 or 6 regular bushings. You want to have the aluminum bushings in there. It came with all plastic wheel bushings for all of the axes. So we kind of fixed it up as we went along. No real biggie, but just letting everybody know, giving them a heads up on what to expect when you receive your printer. Just a little word I want to say on that. When I got my first printer, it was a S5, not a 5S, S5 custom. It was called Creality CR10. It was the 500 by 500 by 500 build area, and it came with a touch screen and a ramps board in it. It was not your typical CR10 unit, and I had a real time with that, trying to get it going. It had a bad board in it, unbeknownst to me. Anytime I'd get anything metallic or magnetic near it, the machine would just flame out for no reason. And being a beginner, it was kind of frustrating dealing with that, but it sort of sent me down a rabbit hole of figuring it out, and it was a little frustrating at times, but I really learned a lot when I went down that path. And I urge anybody to get into their firmware and start exploring their machine. Really makes you a better printer, makes you a better mechanic and a better printer, and it makes you more one with your printer. So not a bad thing, totally not entirely a bad thing, but in the case of a lot of people, they get real frustrated. They're not mechanical. They don't want to sit and figure a bunch of stuff out. They just want to print. And this probably isn't the machine for somebody like that, unless you want to learn. But that's kind of really my opinion on it, kind of an overview. But this is the beginning of the second part of the video, and I'd like everybody to just look through it. You'll see what I've done to it. Judge for yourselves, and I'll do an epilogue follow-up when we're done, and we'll talk about the prints that this thing put out, and I'll kind of wrap it up with my overview of what this printer really is. So with no further ado, enjoy the second half of this. Thank you. I thought I'd film this while I was putting it together. I kind of thought maybe I'd put it together and we'd do a quick evaluation on its performance, but as I started lashing this thing up, there were a couple things that I saw here. One of them was this, and when I flipped it over, I thought, okay, we'll take a couple wrenches and there's going to be some eccentric bushings underneath here, and there aren't. They are plastic bushings. Now, I know as a fact, because we stock bushings here, and we sell these eccentric bushings for people that want to upgrade their tables. I know these bushings are real expensive to put in here, so they really cheaped out there. They saved themselves a few bucks putting plastic in here. I'm not a big fan of that. I was immediately disheartened when I saw that they did that. So I went ahead and I thought, well, maybe they've got slots on the top of the table. I went through the instruction manual. They don't give you any instructions on how to tighten this up, so they kind of leave it up to the poor guy to figure it out himself. So we're just going to take a little deeper look into this. Bear with me. I already pulled those wing nuts off. Off comes the heater. This is a kind of a nice looking heater here. It's all aluminum, and it's got all the looks like all of the heat resistance heat wires are. But you're seeing what I'm seeing as we pull this apart. I did not take this apart beforehand. You see this cheap, this is basically bad masking tape, not even masking tape. You don't do that with electrical wires. You don't shoddily tape them to, look at it, it's falling. Look at this. Can everybody see that? This is actually, the wire just came undone. Gosh, this looks like, well, we're going to look into this a little bit more. This is actually a thermistor, so I guess I'm not too hot about what's happening here. They taped the thermistor into place here. Come on, guys. This is this is really where the rubber meets the road on your heater. That's dangerous, because if your thermistor isn't telling your heater to turn off, your heater will just keep going and going and going, and that is dangerous. I don't know what the capacity of this heater is. And we can get the model off of this Mark III heat bed, PCB. It is a nice heat bed. You can see the little coils go back and forth in here. I really like the heat bed itself, but as I mentioned, we got a problem here. Anyway, so that's an observation. We'll lay this aside. Let's get to the bottom of this. Okay. I'm trying to think. I'm trying to be candid. I'm trying to think that these screws have an adjustment. With no instructions on how to do that, we're kind of left with our own assumptions on what this is. They don't appear to have any adjustment. Not a lick of adjustment in here. And then these would be the inner rail wheels. There's just no adjustment in here. This is pretty disappointing here. Is there an eccentric in the wheel? In a bushing inside the wheel? No. There's just no way to adjust that. Looking this over real carefully, there's no eccentrics in here, no eccentrics in there. Guys, if you buy one of these, I sell these eccentric bushings. This is why I sell those. A lot of these printers, where they need to put those, won't put the eccentric bushings in there. Okay, this side, you got this wheel and this wheel are tight. This wheel and neither one of these wheels are tight, so you got a real issue with this one. I'm gonna cut them some slack. Now, if the two had eccentrics in them, you're only going to go so far, because you can come out to this. You need to captive it in with the two outers. So there's no reason that these don't have, other than the expense of putting them in. And I mean, they're not just spin, but I mean, they're a 1/16 of an inch away from the rail. You saw me rock it back and forth when I had it out earlier. There's just no way to tighten this. I'm going to go ahead, because I'm putting this machine in service. This wasn't a paid advertisement for this machine. This machine is actually going to be in service here. So I'm actually going to take the time and put those bushings in here. And I think what I'll do right now, if I assemble anything else on here, it'll be in the way for me to finish this part of it. So I'm going to end this session. I'm going to end this session right here by saying I'm going to design a kit with these eccentric bushings, and it's going to have 4 eccentric bushings, and the bushings rotate the axles and bring the axles in closer to these. They look like they're within that range, just a millimeter or so away on both sides. And I'll design the bushing kit for this to work with the rest of the hardware that's here. So that being said, anyone who has one of these and has the same problem, or buys one of these and wants to fix that, you can contact me. I'll put together a little package for you with the 7.2 millimeter drill bit. We package this for other machines, for other kits. 7.2 millimeter drill bit that is the size of the inner collar of the bushing. But anyway, we'll be back with that. What I've done here I'm just going to hold them up to the camera. I've taken six bushings altogether. These bushings are equal to these bushings here. This is that eccentric bushing, and if you're not familiar with how this works, you can see the hole in the center of this part of the flange that sticks up. This part of the center, and you've got about, let's say, I'm going to say it's about 2.5 millimeters right there. It'd give you about 3 millimeters of distance that this will span right here. And that's enough to tighten it up. We use that as the center now. We know that it doesn't need to go 3 millimeters, so we know we have plenty here to bring that in. And these spacers are the equal size to the shoulders of these spacers. And what I'm accomplishing here is I'm replacing these two inner spacers on these wheels, so they're equal in height, so the wheels aren't off. They're on the same plane. They're on the same plane as they roll on here. One wheel won't be up and one wheel won't be down. So we stock these. We stock a number of different size bushings like this. We stock 2 or 3 different types of these eccentrics. These happen to be 5 millimeter holes in here, and we're going to be replacing these 4 outer holes. To do that, we need to drill the holes out to 7.2 millimeter. This is 7.14 millimeters, and that extra couple thousandths gives us enough play in there so that this isn't too tight, it doesn't bind. So there's our drill bit. By the way, we get these in the kit. We had to buy like 500 of these things to get a good deal on them, but we bought enough of these that we can supply them in the kit with the eccentric, because you won't find these at the hardware store. They don't cross-reference to an SAE size, so you really have to use this exact bit right here. So this is your bit. By the way, they fit in an American drill, so you don't, no worries there. Okay, that's good to go. That's ready. We're going to start by pulling all the screws out. I'm going to replace these with the standard metal bushings, and we'll put this back in. I'll just reinstall them while it's in here. I think that's the fast way to do this. So in order not to bore anybody, I'm going to zip past this real quick. I could put this on time lapse, and I could entertain you guys with some special effects, but I'll be right back with these changed out. Then if I get to a technical spot in here where you need to see what I'm doing, or I have some explaining to do, I'll focus on that, and we'll do that real carefully, but not to waste the time on foolishness. We'll spend the time on actually learning something. So I'll be right back. I've got these 2 installed already, but I thought it would be worth you watching me do this. The center ones, I put the regular spacers in. These are the plastic spacers that I replaced with the aluminum ones. Now, it doesn't matter if these are the size of the plastic spacers you're taking out. There's plenty of room underneath here for clearance if you use the other spacers. I've got maybe 1.5 millimeters underneath here, and I think that's the concern of using the larger spacers. But the smaller spacers, I think they were about 1 millimeter shorter than these, and they worked out well. What I'm going to do now, I've replaced the 2 with the standard spacers, the 2 outside with the eccentric spacers. So this one's a little stable on this side. Well, not as stable as I'd like it to be, but we're going to replace these now. Then I'm going to go through the adjustment process of these, and I just thought that would be something worth watching here. So I want to do this as quick as possible. Everything's already hooked up. Got our spacers over here ready to go. Wrenches, drill. Okay, I'm going to pop these out quick. Okay, so we're going to take, this is the 7.2 millimeter drill. We're just going to pop right down through the center. Nice and consistent. This is steel, by the way. Okay. And this is where we install these eccentrics. These eccentric bushings. We just put the wheel, the bushing. We come through from the other side like this. We're gonna need to clear that. So, okay. Probably the best thing to show you is you'll be popping these in to the hole like so. Okay. And then the wheel comes up against the bushing, and the axle or bolt drops down through the middle of the wheel. I hope everybody can kind of understand what's happening here. Anyway, okay, so this is number one. We're going to put these in loose because we're not sure which way that eccentric is pointed on here, at least till it touches. Okay, I'm going to back off just a little so we can play with that eccentric just a little bit. We don't want to bind that. We'll sneak up on this next one here. So I'm thinking this is okay, and we're just basically replace the bushings in there to keep those wheels aligned in a datum with the outer wheels. So there's still a little slack. That's because we need to tighten this one up just a little bit more. I'm going to flip it over before I do that. Back to this. Okay, we've got all of our screws in. Just going to real quick show you what we did here. We've got all these wheels in. They're all pretty loose. We want to kind of make sure the trajectory. This thing isn't doing one of these things, but this is from the Creality. This happens to fit. This, I believe, looks like about a 10 millimeter, and this fits the outside of those eccentric bushings. So what we're going to do here is we're going to turn these bushings, and I'm pushing this plate against here, and I'm just keeping my eye on which direction that wheel's going when I bring it in. It's going out now, so if I go this way on it, it's bringing the wheel in closer. I'm starting to feel friction on the wheel. We're going to do the same thing to this. Okay, we're pushing that out. I'm getting some tension here. I'm good right there. I'm going to try this one over here one more time. We got good tension here, and now my finger's slipping on the wheel. And I think that's really tight. I'm going to back off just a little bit. Okay, now I can still turn this wheel. This one's a little bit looser. I think the name of the game here is to get these about the same. Now I'm able to eyeball down this crack. You can't see from where I am, but I can see this edge right here, and it'll be the same on this side. You just eyeball that, and I'm parallel to the side here. I've got these two tight. All three of these wheels are tight. They're all hugging this rail right here. We're going to do the same thing to this one. Got nice tension on this wheel. Nice tension there, and okay, it doesn't matter which way you go on these. One way or the other, it's close. It's going to do the same thing one way or the other, okay? I'm going to leave just a little bit of tension here. Let them slip just a little bit, because when you tighten them up, they're going to draw up and they will pull a little bit closer. As a rule of thumb, we're going to do that. And we got this. Okay, guys, this is the way it's supposed to be. See this? Nice and free. No wobble. No wobble this way. That's the feet are uneven on this. It's actually my table. That's what you're seeing, but there's no wobble on this. It's really stable. We'll probably address these little bolts over here. If anybody's interested in buying the springs and the kits for these are toys. I mean, literally toys right here. Bad spring, good spring. Let me tell you what the springs do other than keep tension on this table. When that's loose, of course, these aren't so bad because they've locked this down. I don't know if you can see this. Bring this in. They've actually locked the other side of the bolt down against the plate. The CR10 bolts are actually loose and floppy in here, and they depend on the tension of the spring to make that work. But you still get, you can see right here, just that little bit of pressure I'm putting on this, such a small fastener that those moment loads are going to give you a little grief right there. This is a real professional class spring here. I've also got the knobs for them and the screws. You'll want to replace everything. The stem is bigger on the screws. I've looked. You don't have to worry about cutting into the resistor tape underneath here is real far. It's about maybe half an inch away from the edge of this screw here, so you don't have to worry about ruining your heater with that. But I just thought I'd bring that to your attention as we move on with this. This is kind of a pain here. I'm really not sure. I think what I would do here, I think maybe a dab of silicone. And the reason I mentioned silicone is silicone will conduct the heat to the plate into that hole, like what I think they had it. I'm going to come along with some really good tape. Okay, it's called gaffer's tape, and it's sort of like a duct tape on steroids. It's black. This is what they use, like bands will use to tape their cords down to the floor as an alternative to this. As an alternative to this. You want to use this, but you want to make sure you're not near, see these over here, that you're not near any conductive surfaces with this aluminum tape. This is real metal. So I think I like this a little bit better. I think Gorilla tape, under the brand name Gorilla tape, I think they sell something similar to this. They call it Gorilla tape, but it's gaffer's tape. You're all set there? That should do you on a permanent basis. Check these connections. This would be a time to lay a little solder on them if you have to. Okay. One thing I also didn't mention, this is a 330 by 330. It is nice to have that bed. We'll do something for an antique motorcycle. And that's kind of what got me into this, was we routed all of our patterns for years and years. I've got CNC machinery, and we made all of our patterns with that. And I converted to I converted to 3D printers one day when I realized not only is it make more sense, but 3D printers can make that technology, that addition technology, can make things that regular machining technology can't. It's just you kind of have to wrap your brain around it and understand what's going on here. We fixed it. We got a nice solid bed now. You know, in the big scheme of things, we talked about comparing this to the CR10. I really can't. I didn't bore you with any of the typical how you put this together. Everybody's seen the CR10 reviews, and you know, everybody's putting these things together, and it's really 4 bolts on the bottom, the hammer nuts on the sides, puts this together, gets it to this point. The table's nice and stable now, really stable. What you're seeing here, this little wiggle, is actually the play in the springs in here. And I even took the liberty of I put in a set of those heavy duty springs I showed earlier, because those flimsy ones, I put them in there and they're just not, it's just not the way to go. If you have any jerk in this thing at all. Okay, now it's really, really stable. Everything's real tight, real stable, worthy now. Now it's worthy, before it wasn't. I don't know any of you out there, if anybody doesn't have the skill to take a drill and do what I did, or is able to get those eccentric nuts or get that kit, I would steer you away from this thing, because it's just not going to perform unless you take care of those little problems it has. You saw gaffer's tape underneath. You saw that loose thermistor with masking tape on. And I'm really not trying to cut this down. Competition is really what makes the game come alive. But the CR10, you know, they did a nice job. They made it come in on a price point. They became the standard of the industry for this type of printer. They well deserve it for what they've done. They well deserve it. This is kind of neat. It's got a little one of these hurt your thumb devices here, Chinese torture device on the end here. One thing really struck out at me when I went to set this on, one thing I noticed, check this out. Everybody see that? That's pretty awful. That is a culmination of a couple different things. I think the big thing is, you know, they used all these plastic bushings here and no way to tighten these up. I did a video on repairing your X-beam on the CR10, and I'm actually going to apply that. I'm going to apply that same technique to this. However, there are absolutely no eccentric bushings in this. This does not sport one eccentric bushing, and that's a little disappointing in my book, because there's really nothing to tighten it up to. At least an eccentric bushing, you can put pressure on one side of it and then bring the wheels in to the to captivate this part here. But major disappointment. What we're going to do now is we're going to go ahead and apply this this technique that I used on the CR10. This wheel is pretty loose here. I don't think there's much hope for it. Once again, these bolts, like the CR10, go through this bracket right here. They go through this bracket, and this bracket, you can't get to that screw, to the other end, to the bolt in this bracket. So if you loosen this, you'll never get it tight again. So we're just going to leave these alone, these two inner wheels. I don't know if everybody can see this wheel and its counterpart over here. You can't see it, it's behind the beam over here. And I'm going to try to pull these in. Now, we did it on the CR10 by grabbing a hold of this bracket, loosening these screws, and then bringing these in. However, the inner wheel will have a rough time. Look at this, isn't even touching here. This is pretty rough. I think what I'm going to do with this one, because this wheel is tight, the inside wheel is tight, so I'd like to just bring these two wheels into it. If I move the whole bracket, the inner wheel is connected to that bracket, and I'll be moving the inner wheel away from that slot. And what we're trying to do is we're trying to clutch the slot. So, I'm trying to pull these against. I'm actually going to put this on the inner wheel. And I'm actually, this time, I got this nice soft, cushy, these Irwin clamps are great for this. We're going to try this. I'm going to actually put it on both of the outer wheels. And I'm just going to put it there so it holds itself there for now. We'll put some pressure on it. I don't want to bend these axles. Actually, I'd probably do it some good if I did. But I'm going to go ahead and pull this out. And my game here is to take the slack. All bolts have a little bit of clearance in the holes that they go through. I'm going to take these bolts all the way to that end of their clearance in this bracket right here. I don't know if everybody can see that, but it's a cheap way of making this thing work. So I'm going to start off by loosening the top one. If everybody can see that. Okay, now I'm going to hit the bottom. Okay, I'm getting some movement out of it. Okay, now I'm going to try to, you can see me rocking it. I'm going to try to get them both. All right, now I'm putting some pressure on it. And we're going to try to get this right back in there again. I'm going to really make this tight so we don't lose what we gained on this thing here. Okay. And it's squishing these nylon, it looks like little plastic spacers in between here. In fact, you can see them mushroom out just a little bit when I do that. Oh yeah. Oh yeah. We got a little something that time. Not a lot, but we got a little something. Now all of our flex, as you can see, is in this. And once again, the CR10 has one of those eccentric bushings on the bottom of it. This does not. We're going to go to the other side and see if we can work this. That X motor is going to be in our way. Let's see if we can get something out of that. I'm going to do something a little different here. I've got the motor is kind of in the way. I'm actually going to use that to my advantage. This bracket is pretty robust here. I'm going to get something in behind there and actually prime those wheels. The inner one is pretty tight. against the rail. So that's hugging in this way. If I can get something in here, use the motor as a fulcrum and just push the wheel. I'll do these two separately. Let's do that. One thing cool about being old is you accumulate all these cool tools. So there's always a tool for the job. This is the one. It's a little pry bar, or they call them pinch bars. And we're gonna just get in there and we're gonna do this. Oh yeah, look at that. Perfect, okay? Try that. All right, excuse my head in the way for just a second. Okay, I'm loosening this up first. I get in here, I'm gonna pinch this. I'm gonna pinch this in with the motor and my chin. Not very pretty, but sometimes you gotta do what you gotta. Look at it, nice and tight, look at that. Bottom one loose, okay. This is one of those jobs where you gotta use a little ingenuity. Get a little leverage on this wheel. I've got this between the motor and the wheel. Okay, and I'm gonna loosen it first. I don't get my hands full. Okay, see what we got here. Oh yeah, you know, I would almost say it's almost over tight, but I know it's gonna loosen up. I know this is gonna loosen up in time. We've got it now. This is nice, really nice on this side. The bottom one could probably use a little more. I couldn't get it out of it. I think we set out to do what we needed to do on it. This is what we pulled out of those other wheels. I just want to show everybody these are plastic bushings. You know, plastic's a great thing when it's used properly. One of the problems we had here, if you could see inside here, these start to mushroom out when you put any kind of tension on them, the kind of tension that you need to hold these wheels into place. So not a good place for plastic. They've had a kind of a run on using the wrong materials on this machine from an engineering point of view. Okay, so this is going to go back and forth. This is going to go up and down. So there's going to be some wear. There's going to be some wear right here. It's going to wear against here. We're going to want to protect that. I would stick some, they didn't go up far enough with this. You'll never be able to get anything around here now. You'll probably just want to wrap some vinyl tape around this part of it to keep this from wearing. This of course goes to your thermistor and extruder. This will be worn through in no time with this screw here. So word of warning on that one. Let's see what else. We're pretty good. I put this on the first time not realizing you don't want this wire getting caught up in the belt here. So this is the proper place for it right over here. And there's no strain relief for it right here. Zip tie it to this. There's your strain relief right there. You can't really go too far with this. It's doable, okay? So we're gonna zip tie this to there. We've got that fixed. We're good. We're good. I'm happy with that. That's gonna work. Probably just kind of keep our eye on that, make sure it doesn't get caught on something. Let's work on this guy right here. We're a little bit loose. Okay, another noteworthy thing. I took this off because of your wobbly cross car. There's no adjustment in here. Whenever this thing goes into a print, you're going to wobble on it. I'm a big believer in just make it right, and that's kind of the secret to making these things really perform well. What we're going to do here. I'm going to take this apart. We're going to do basically the same thing we did with the drill bit and our eccentric bushings. We're going to replace the plastic bushings in here, and we're going to oppose these. These will be the non-movable bushings or the stable bushings. We're going to counter them with the center hole here. So when we tighten up this eccentric, it will pull both of these wheels down equally, pull all the wheels into that. They're loose right now, all three of them. Pretty nuts. But what I'm going to do now is I'll replace these two. I won't bore you once again. We'll do this off camera. I'm just going to replace these two plastic bushings that are in here with these two aluminum bushings. And I'm going to drill this out with the 7.2 millimeter drill. Okay, as we're putting these bushings in, okay, I put the two top bushings in. On the CR10, they've got two little bosses that are actually welded to this piece right here. They're actually spot welded onto that piece right there. This one has these two, well, I guess these would be extended bolt deals. I'm showing you this because we're going to fix this right now. What happens is this extends through these holes, and because these bushings that we just put in here, the old bushings are this long and the new bushings are that long, we have to take some off of these threads. However, instead of taking them off the threads, we're going to space the threads out with two little 3 millimeter nuts. And what that'll do, these are about 1.5 millimeters wide right here. That's about as much as we'd have to take off the end of this, but we can just leave it on there now and lock it into place. Your hot end consequently will be out that much further in that spot. So when your hot end bolts on, it's going to be out another 1.5 millimeters this way. I know for a fact, because I looked at that fang over there, you should be good with the fang. We're going to test how that fits behind the fan here. I think we'll have clearance behind that. If not, my plan is to bolt a stinger to this back plate anyway. So for me, it's not going to matter. However, to be fair, I'll come up with an ulterior plan for anybody who's going to be using the stock hot end on here or a micro Swiss on here. And we'll fix you up with a plan if you wanted to do this to get you by. And it certainly doesn't hurt to have a little more airflow behind these bolts because the way they come from the factory, that the back of these cooling fins are almost up against here. You can see this tiny little hole where air gets to blow through there to cool this hot end, cold end off. Probably not enough. Okay, now we have nothing sticking out of the back. We don't have to worry about the studs rubbing on this right here. So we're good to go now. And you know, as a precaution, if we do get a rub, we can always pull this vinyl strip off here. I do like these colors though, something I did not mention earlier. That's pretty neat. Okay, so our next step here, I'm going to go ahead and pull both of these nuts down over here. By the way, I don't know if I mentioned it. They give you a number 1 Phillips screwdriver with this kit. These are all number 2 Phillips screws, with the exception of just a couple of them. Be aware, get yourself a number 2 Phillips. If you're not familiar with what that is, go down to the hardware store and just ask. If you're going to own something like this, you might want to invest in a decent number 2, because you end up stripping out screws, and I don't know, it's pretty aggravating if you ever work on this and you strip screws out. All of these screws are number 2s. All of the brackets I put on the sides, the screws that go underneath, normally that were cap screws for the Creality, are number 2 Phillips heads on this one. So if you plan on putting this together and you don't want to fight it, I use this. Probably shouldn't show you, I cheated. Little number 2 Phillips in my drill. You get a hand screwdriver with that tip in it. Handy to have around the house anyway. Okay, so right now we're going to go and take that drill we're going to drill this out with that eccentric, for that eccentric bushing right here. So I'm going to do that real quick. Really don't have any reason. Put it on our drill. Okay, we're just going to watch where those shards fly. I kind of don't like this part of it, but if we're careful, don't put your hand behind here. The two spots where the belts fasten on are clear from where you are. Try to drill that whole square. Okay. Old bushings, put those aside. This is the hardware that we're going to need. Here's your eccentric, your axle. Now remember, we need a washer because the head of this eccentric is now going to be about the size of the nut, and you want something to kind of back it up so it stays in the hole there. Okay, so bushing first, just pop it through the hole. Do it either way. Okay, so now I like to refer to this bolt as our axle. I was tempted to grab that drill. Okay, we're almost there. Okay, we're going to get this a little snug, and we want to be able to turn that bushing in there, but we really got lucky. You see how we get the wrench down inside here to turn that bushing. Okay, and I'm just going to say that's good. This is no binding. It is totally stable. So we're good to go, guys. Check this out. Look at, absolutely no wobble. Wheels still spin. We're not binding. Everything's good. We just fixed this machine. There's no wobble. Look at this. There's no wobble to this. You saw what this was before. There's no wobble to this. This is just flex in the beam. I'm pushing on this pretty hard. That's it. I'm going to go ahead and reassemble the hot end now. We're going to go ahead and run it with this hot end and just kind of see how this works to finish up our evaluation before I put the stinger on. I've also got to try to hunt down which chip is in there, so we know which Arduino chip that we're dealing with when we do the firmware for that. So I won't bug you with the rest of this putting this on. I'll probably run it and show a print after we're all done here, but that pretty much sums it up. Well, there you have it. My opinion on this is that it is not a CR10. It's not a CR10. Anybody that thinks it's a CR10 or competes with a CR10 has the wrong idea about this machine. The overall frame and configuration of the machine itself looks like a CR10, but that's really where the similarity ends. There were a few things. I dug into this a little bit deeper, what kind of board it has and what kind of problems they're having with this right now. And it seems like it's a firmware problem. The mechanics of this, there's no reason why it shouldn't, at this point, after I've straightened out all the little problems, loose parts and missing pieces, plastic pieces, with the correct ones and tightened everything up, there's no reason why it shouldn't be performing like a CR10. But there's, I think the problem lies in the firmware for it. They've got crappy firmware, one of the crappy settings in the firmware. One of the articles I just read about this is that, and I've experienced this myself, it will not save its home. After it gets done, you'll save the home and it saved all of the axis positions. And when it's done printing, you go to print something else and it's 2 millimeters up above the build sheet on it. And that's a little bit frustrating. I went in and tried to adjust the home. The second time, unbeknownst to me, the nozzle was still on, and I burned the board in a couple places. I scarred it in a couple places, and those are little frustrations that I've been printing for a while, and those are frustrations that would be pretty hard for somebody that's just bought one of these thinking that they're getting a CR10 or CR10S. So I've showed you the prints that this puts out. I'm not entirely convinced that it's the machine itself. I believe the problem is in the board and in the controller at this point. I'm not sure which way I'm gonna go. I'll start out with a firmware upgrade in this. That taught me something about print quality and firmware, which I'm gonna have to attest to the problems that we're having with the prints on this. I'll probably do a follow-up if I find out that it was the firmware on here, which I'm about 99% sure that's what the problem is. And we'll do a little follow-up video on this. I really want to give it a good score if it deserves it. However, you've seen what I've done to it. Everybody's intelligent enough here to make their own mind up of what you've seen and judge for yourself whether it's a good machine or bad machine. It really depends on it's a good machine for you or a bad machine for you. So it's kind of a fit thing as far as I'm concerned. I'll keep it around. I plan on upgrading a few things. I'm actually going to lose one of the Z's and go to a mechanical dual Z, take one of the Z motors off. Then I know it's true. The Z's are true. I think I've got a little Z fluctuation or something going on here too. And replace the belts. The belts are like rubber bands on this thing. I can't say enough about the quality of the belts and the quality of your prints. Probably one of the first things I'll do to this. But all in all, the score on this thing, you're not going to get it from me because I don't score. I really don't care about that. I've done so much to this machine that it's not a stock machine anymore. If I was to give it a score, it wouldn't be a very good one because if we're comparing apples to apples, it does not meet the criteria that a CR10 of what a CR10 is. And that's really basically it. Can it be a good machine? Absolutely. There's nothing too tough about this. There's no magic going on here. The little magic in the box over here can be fixed, and it can go on to live a real long, happy life here in our little printer farm. So, guys, I really appreciate you coming here. Stop back when I do another review on another printer. I've got a couple coming up here, and we'll go mechanical on you. So I hope you enjoyed this video and got something out of it. I'm Dave Aschenbrenner. Please visit my website, 3dprinttoform.com. Thank you.